Okay, so you sign up for a course in software testing. What is it? And why is this important? Computer software runs the world. If it crashes, even briefly, the impact to a company's bottom line can often be measured in millions. But crash it does. Well-publicized failures from both industry and government have underscored the need for mission-critical software to withstand harsh conditions. Before it sees the light of day, software must prove its reliability under a white-hot beam of rigorous interrogation. It must be poked and prodded, squeezed and stretched, trashed and torn. In other words, it must be tested. And when it does fail, we call that a computer bug. The world's first computer bug was discovered in 1945 by then Navy Lieutenant Grace Hooper, now retired Admiral Grace Hooper, and the inventor of the COBOL programming language. The computer was called the ENIAC. It was as large as a gymnasium floor, and there were relays all through inside of this computer. The first computer bug was a moth that happened to get across relay number 70 in panel F and caused the computer to fail. And in her technical journal, Admiral Grace Hooper took the bug and put it in there and said, "First actual case of bug being found." How do we know when code is ready to be shipped? This is an ongoing management discussion with every software product. If you ship code with lots of defects, it can cost you your reputation, let alone the cost of replacing products. If you wait until the code is perfect, you will never ship the code. The reality is that companies knowingly ship software products with an acceptable level of defects. So how do we measure software defects? Most companies measure it as defects per clock, KLOC, or short per defects per 1,000 lines of code. It varies by industry, language, and application, but that's the most common measurement. Some interesting quotations. The industry average is 15 to 50 defects per clock. Microsoft is 10 to 20 during in-house testing and 0.5 defects per clock in products they ship. NASA is 0.004 in deployed software. Since code is written by humans, it will have errors, and it costs money to find and remove these defects. The industry average is quoted as $5 per line of code to remove the defects. NASA spends $850 per line of code. If you think about it, if you were an astronaut on board the space shuttle, you really wouldn't want to worry about defects in the code controlling the computer that controls your oxygen flow. NASA spends more money. So, you want to be a software tester? Here's an ad you might see in the paper. Software tester wanted. Position requires comparing an insanely complicated, poorly documented product to a non-existent or woefully incomplete specification. Help from original developers will be minimal and given grudgingly. Product will be used in environments that vary widely with multiple users, multiple platforms, multiple languages, and other requirements yet unknown, but just as important. We're not quite sure how to define them, but security and performance are paramount, and post-release failures are unacceptable and could cause us to go out of business. So what is software testing all about? It's about constantly making choices and understanding the complexity in running tests and examining the results to choose between the many possible variables in a testing environment. Will the software work as designed? Will the software perform the functions for which the user bought it? Will the software perform these functions fast enough, secure enough, robust enough, and so on? So is software testing an art, a craft, or a discipline? The first book on software testing was Myers' The Art of Software Testing in 1979. Craftsmen are people who learned on the job, as many software testers have done. A discipline requires systematic learning and training in multiple fields, as evidenced by Austin Community College's degree plan and certificate in software testing. Therefore, software testing is a discipline, and ACC's software testing curriculum includes courses in multiple fields: programming, databases, networking, operating systems, security, computer hardware, technical writing, mathematics, and social and behavioral science.